So it's available for download from our website, and it's free of charge under GPL. So really pleased about that. So we can, and again, the full documentation is on Google's developer website. So Phil Boots is one of our guys would say in the office. So moving on, the technical challenges was one of the main things with this product. Like any product, it's great that you can maybe build one. You know, building a prototype is fine. You know, you can hack it together from whatever you have handy on your desk. But knowing that you're going to scale up this product, and certainly, you know, this is the full intention of this product is to scale it. With NCTech, the markets that we've been in, they're very exclusive sort of commercial markets. So each product that we have, we can customize it, tailor it to all the individual needs of all these businesses. But with consumer product, we fully understood from the outset that, you know, this is going to require quite an effort behind the scenes to ensure delivery, fulfillment, manufacturing, support. All these things are in place on a much grander scale than what NCTech has done. So with scale came those challenges. So what we did is, with any camera, you know, you've got to focus lenses. This camera has no moving parts. So with the lenses, they're all set at a fixed infinite focus. So every single lens, and there's 4 of them per camera, you know, that's thousands of lenses that need focused. If that was given to an individual to do as their daily job, they would probably be not very happy about it. They'd probably go blind. So with that, we had to devise an automatic way of focusing these lenses. So we wrote software, we did, you know, all this sort of stuff, motorized units, and allowed us to scale up our focusing rates. Calibrating those lenses, we had to develop a way of really fast calibration of every camera that we ship. And I'll come on to why we calibrate in a few extra slides. But the reason here is we want accuracy in what we're taking a picture of, but we want accuracy in our stitch as well. So calibration is essential, and right down to how the light is entering the lens. And these things needed to be done in a large room that we developed. With every camera takes a picture in the middle of that room, and then our software auto detects over 850 surveyor's targets inside that room, and rebuilds the environment that it's in to sub-pixel accuracy. So that was something we had to develop, and we had to streamline that as well, make it really fast. And then things like parallax error as well. With a camera that has multiple lenses, there's no fixed nodal point of rotation, so we needed to resolve parallax error if we're going to produce a great stitch or image in a confined space. Good news is we did solve all those issues, and they're all running on board Iris. So what else is running on board Iris? We've got HDR. Now HDR is something that you guys will be well aware of. With the challenges of 360 imaging, you don't have the ability to look away from the sun. It's, you know, it's there as well as dark areas. So you need to do bracketing and exposure fusion. So again, we developed an algorithm that automatically checks the entire range throughout the range and changes a dark image into a fairly vibrant image. And that all happens on board the camera as well, fully automatically. So again, when you're doing street view imagery where you're inside a restaurant, this is going to be extremely important to see outside those windows where they're not, you know, it's not blown out and overexposed. So range finding. This is something that we developed last year, and again, as part of this project, we were really keen to get it ported over onto Iris. So we spent some time, and we now, as part of our development in our commercial industry, where we're working with laser scanning technology and our calibrations that we do there to quite a high degree of accuracy, we transposed some of that IP over, and we felt, okay, we'll range find from within the scene. So it's very similar in the sense of you know, the jump system from Google, where they have an array of cameras and they create multiple virtual points. We're doing the same, but we're doing it from one camera. We're not doing video, we're doing one image. So we don't need thousands of computers, thankfully. We can do it all on board the device itself. So from this image here, we generate a range map, and then from that range map, anything that's close is in white, and anything that's far away goes to dark. And from that, we can calculate distance and then from that it can help us with our stitching and correct for parallax. So moving on from range finding, what else do we do? So here's an image which is actually, this is an early prototype video. We've got some new stuff now, but I'll focus on this for the moment. So last year when we developed this, we explored about finding depth information from within panoramas. So what we've done here is we've taken a single shot from iStar and then we moved the camera slightly and take a second shot just to give us extra overlap in what we see. And then from that, it's managed to, hopefully if it runs, we should be able to see a little bit of depth information from the scene. So we'll just zoom down, look around, see the quality of it. But then, as you move slightly, you should be able to see a little bit of range information coming through the picture. So it was working. You obviously get black areas where the camera hasn't seen beyond, behind that. So if you move the camera and you take a few more shots, what will happen? Well, you'll build a much more depth in 3D model with millions of points of data. And so you can actually construct an entire 3D model just from 3 iStar images. We moved. That surprised me there. I wasn't expecting that. So the good thing about this is we spent, to create that takes no time. So when the user takes a picture, takes another picture, our software will auto-register those images, create the 3D model, colorize it, and export it all for you in 2 minutes. So it's an incredible, powerful program that we've developed there. Moving forward, this next little clip that I'll show is from our work in the laser scanning field, where we're actually working with real LiDAR data. We're not generating it ourselves. We're actually pulling in real measurement information. So the next slide here is a little video where the black and white information is the range information that you saw in the last slide. But now we'll blend in our colour. And that's, again, processed fully automatically with no user input whatsoever. You take the scan, you point to our images, boom, it's done. Minutes, 3 or 4 minutes to generate what is possibly 100 million points of data easily there. And that is millimetre accurate. Sorry?
How many pictures it took to get that?
To take that was 7.
7 only?
7 around the church. So the main thing here is automation. NCTech is automation. We're not into, you've got to click this menu, do that, and it's just drag and drop, bang, that's it. With this, the main thing that we see here is people look at our devices and go, you've got fisheye lenses, you're going to have chromatic aberration, you're going to have parallax issues. You look at the data we're producing for the engineering sector here. It's not about looking at the imperfections of the device. We can solve that in software, and we have done. We've removed the chromatic aberration. We only use the best bits of the lens, and we only use the best pieces of information from each scene. And then we blend it all in, cross-reference it, auto-register it, and there's no parallax, and there's no stitching errors in any of these 3D models because we don't do stitching. So that kind of sums up what our developments have been on. The new camera is available to order today, $1,999. We'll be shipping in a couple of months. Thanks for your time.
Any question?
First of all, thanks very much for the presentation. Pretty impressive point cloud over here.
Thank you.
I'm just curious about the file format of the point cloud.
Yeah. At the moment, what we've done is we don't want to spend too much time figuring out user interfaces. There's already a lot of them out there. Can you hear this still? There's a lot of good companies out there who already work in the point cloud market. You've got Autodesk, you've got VSys, there's all these great companies out there. So what we've done is we've actually teamed up with all those guys over the last couple of years. And so we've created a plugin. And so what you saw there was achievable in our own software, where you drag and drop the data in and it generates a file format that we were happy with, which was E57 or an LAS file, which is a fairly generic file. But we knew that to convert, if you're using a Leica system or a Faro or a Trimble, they have their own file formats as well. And you want to stay in their native software. So we wrote a plugin, and we sent that plugin out to all these manufacturers. And today, we've already got Trimble, Leica, VSys, and Autodesk fully implementing our technology into all their applications, so that when you have an iStar or potential new iStar products, those images will just come straight into that software, and you'll just see it colour within your native program, so you don't have to worry about file formats. It'll just support our own native images straight from the camera. Does that answer the question?
Thank you.
Right.
Impressive work. I'm really glad to see this stuff becoming a viable product. I wanted to ask you if the depth map, which is a very nice clean depth map indeed, is equivalent to the point cloud or is derived by a different kind of algorithm?
The depth map algorithm that we've developed runs on board Iris, and it now runs on board iStar cameras. The iStar cameras are 50 megapixel, and there's new things coming in that era too. Iris is running at 8K at the moment, and the depth map is slightly different. The lens configuration is slightly different with Iris also, just due to trying to get the cost down on the product to make it consumer. But we tried our best to port over as much of that IP on board this device as we could, but without taking it too far that it would take 10 minutes to process an image. So, when we're working with architects, they're using quite powerful PCs with gigs and gigs of RAM, and they're throwing around these huge point clouds. So to process in 2 minutes is nothing for those guys. It's hardly enough time to put the kettle on. Whereas with this, we need the photographer to have it as fast as possible, so that he can present that, show it, move on. And so we've scaled it back a little, but the depth map is very similar. It's the same algorithm, just pulled back a little bit from what we're doing because we don't have quite the resolution yet.
Do I understand you correctly? You mean that the Iris does not spit out point clouds, only the iStar spits out point clouds?
At the moment, we're not spitting out point clouds from Iris. It's doing it internally to give you a better stitch and correct for parallax. But at the moment, until this product comes out, we're trying to, we've got an engineering sector there that has a product called iStar that's designed for that. We don't want to bring out a product that, potentially, the iStar's a higher resolution product. We don't want to bring out a lower end product to compete with that at this time.
Last question.
Hi.
It's my birthday tomorrow.
You know the funny thing? It was my birthday yesterday.
Congratulations on what you've achieved. It's quite amazing, and I think nobody's thinking about the big nadir hole anymore. Or maybe just a little. But how is there, like, in the future a web-based application available in which you can offer these 3D models and take measurements within them?
Well, yes. We have, if you go to our website, we just put our website live as you're in here. So we've got a brand new website. It's went from black to white. We've got Iris on the home page. We've got Google highly featured there. Those guys have been fantastic to work with. Really appreciate that. We have got there is systems there at the moment called iStar Share, and it's a platform that's there for hosting your images and sharing and creating all sorts of stuff for sharing images. The plan is that coming soon we are going to be revising that platform, and it's going to include much more of the 3D spatial content that we're generating now. So that's something that we internally have been aware that we've needed to supply. We're currently working on it. It'll be something that comes out soon. Yeah, these products are not shipping until August, mid-August onwards, so it gives us a few months to just get these systems moved over.
Sorry, just on the nadir hole. Having seen the point cloud, I'm just gobsmacked with that. It's amazing. So please make it available out of this. But how feasible it would be to take 2 shots to fill the nadir holes? Basically, just offset the camera.
Quite easy. That's the whole point. We don't bother about the nadir, and we're probably not going to try and address it in optics because you can just move the camera. It's so quick.
Yep.
We can fill it in software. Google are doing that anyway with Street View. So it's certainly something that we will do. There's I don't want to say too much at the moment, but there's a lot of new things that we are bringing out this year that will probably be very exciting. There's other products out there that do like the Matterport systems and things like that are available.
So
there's new things coming from us that will probably address a lot of that as well.
Yeah. So we have the Matterport.
Oh, you do?
Yeah, and so I'm quite familiar with this, but it's clearly moving extremely quickly.
Yeah.
But what you have there is quite astonishing, and if you can automate the filling of that hole, then you're not going to get me whinging about it like I was when I was a
You weren't whinging, were you? Will do, thank you.
Incredibly impressive, thank you.
Thank you.
Hi, just a quick one. Very good, excellent. Thanks so much for having me, by the way. And, I just wondered about, is there any sort of manual triggering? I know you've got an app that will go with this, but is there ways around? Is there like an in-out port that you can basically trigger the thing in exactly the way you want it?
Yeah, the way we can control this at the moment is by two ways. There is a physical button on it, but then you're on a timer. There's the web interface that we've built in, or there's the API at the moment. We also do have an SDK that we developed for iStar for mobile mapping. So currently people put these on vehicles and take so many images as they drive. These cameras already support extended GPS functionality, so and even nautical GPS as well. So whatever you plug into the USB ports, it'll stop using its own internal, and it'll start reading in that high accuracy from an IMU or your inertia unit. It'll start reading that in. So to answer your question, yes, you can trigger it, but at the moment, because this is a brand new product, we don't know how many of these high-end things that we've done in iStar we're going to allow to be compatible with this product, because we've got, there's other things coming, and we need to just kind of stagger our release so that we can get a nice platform out there. I know what you guys are after. I think this is some way towards that, but I think there's probably, if you're getting into that sort of area, there's probably other things that would probably satisfy you a little bit better than that.
I'm remiss that I don't know the answer to this, but in which countries can we purchase these cameras?
Well, what is the countries we can purchase this in? Andrew, do you know?
Worldwide.
Worldwide, is it? Worldwide, is that right? There we go. Great. When can you start? Is the website up, the purchasing? It's live. Right? Not now.
I have another.
So, I'll come to it.
Okay.
Yeah. Just a practical issue. How do you not get in the picture when you're making them?
It's funny that we, very early on,
You get in the hole?
you on iStar, for example, which has a touch screen on it. This device doesn't have a touch screen. That's not a screen. It's an on-off switch up there. But the way you not in the picture is we have a thing called walk-around mode. Yeah, and once you're in walk-around mode, it tells you to get out of the way, and then it takes another picture and fills in the gap. So it'll capture half of the scene, and then you move, and it captures the other half, and then it blends the two together. So it saves you hiding under the tripod and running away. Yeah.
We're curious about would artists shoot videos for us? No? Because I know
You know-
iStart is just all about imaging.
You're sitting next to colour with GoPro. You want video? There's your guy. But you know, it's a good question. No, we didn't design this product for video. Yeah.
And as we know, on RVRPA 2015, most of the manufacturers will have a coupon code. So if we pre-order the device during the meeting, we will have a coupon code.
I think so, yeah. We'll set that up for you. So everyone in the IVPRA will put a product code up. So if you do order, we'll do something on the price for you. Not much.
Okay, great. Thank you very much, Neil.
Thank you.
Great
Thank you, guys.
product.
Thank you.
So, we were supposed to get Synoptic, but they didn't show up. Our next speaker is... Are you? Okay, finally. That's